So now we're going to learn about waves. Waves are a disturbance that transfers energy. There's going to be two types of waves. The one that we're going to learn about first, and that this video is going to primarily be about, are mechanical waves. We'll come back to them in a second. The other type of wave is called electromagnetic waves. Electromagnetic waves take up about a third of this unit, so we're going to explore those in depth in a little bit, but I wanted to let you know that they were there and what they were. They are disturbances in electric and magnetic fields, and some examples of these are light, like visible light that you can see, radio waves, the waves that make your radio station, X-rays, microwaves, and UV light. So microwaves like you cook your food with, UV light comes from the sun. Now mechanical waves, which is what we're really focusing on, like I said, they require matter to travel through. These ones don't, these ones do. They require matter to travel through. And some examples of these are sound waves and ocean waves. So talking more about mechanical waves, there's going to be two types of mechanical waves, and that's based on their shape. The first one is a longitudinal wave, sometimes called a compression wave. In the wave, particles move back and forth horizontally. So if a longitudinal wave were to hit me right now, I would move back and forth horizontally. You can think of this best example like with a slinky or any sort of spring. The rings of the slinky, rings of the spring compress close together, then spread out. Compress close together, then spread out. Moving back and forth horizontally. Then you have transverse waves. In the transverse wave, the particles move up and down vertically. So if I were to be caught in a transverse wave right now, I would move up and down vertically. Transverse wave. Example, if you took that same slinky and were now to make it a transverse wave, you would move it up and down like that. Think of like a rope. You can easily do that to a rope or a string of some kind. But I wanted to keep the slinky reference the same so that you could see that you can make, certain objects can do both of them. So now that we've got those two waves, we need to describe the waves further, talk about their characteristics. So the first characteristic of a wave we're going to learn about is the amplitude. The amplitude measures how far the particles moved from their resting position. That means like the furthest distance they traveled before they came back to where they started, after the energy has passed. In a longitudinal wave, it would look like this. If this is where the particle started, was along this line, and now the wave is coming by, the farthest it might have gone was way over here. That distance between where it started and where it finished would be that amplitude. In a transverse wave, you've got your resting position, and at the very top of the wave, or bottom, depending on what that particle did, that distance between the start and where it went would be the amplitude. Now you've got the wavelength. That's the distance over which the wave's shape repeats. So just one version of the wave shape. So for example, in a longitudinal wave, you might start with the compressed part and the wide part. As soon as the compressed part starts to repeat, you're on a new wavelength. So one compressed part, one wide part would be one wavelength. In a transverse wave, you might have an up part, a down part, but as soon as it starts to be the up part again, you'll want, that would be one wavelength. More on describing these waves. The wave period is the time it takes for one wavelength to go by, okay? In a longitudinal wave, for example, it would again be that same wavelength. The compressed part, the wide part, and as they go by, maybe it took 3 seconds for that to go by. That's a really slow wave. Most waves we learn about are really fast. This is obviously an example, so it can be whatever speed it wanted to be. So the compressed part, the wide part, that made for that wave period to be 3 seconds. This transverse wave, I drew it with the same wave period so you could see the two different shapes. Again, you start with that top, the bottom, and as soon as it starts to repeat again, we were at 3 seconds. That's a 3-second wavelength. Now we've got frequency. Frequency refers to how many wavelengths pass in a given time. Most often, you're going to talk about frequency in seconds. If you're talking about frequency in seconds, the unit for that is hertz, H-E-R-T-Z, okay, hertz. In a longitudinal wave, the one for above, you would have had in 1 second about a third of the wave, so 0.3 hertz, okay? Same for the transverse wave above. Again, about a third of the wave, so 0.3 hertz. So I drew you one. Like I said, most waves, sometimes old stereo systems, you'll see you can measure the sound in hertz, or the pitch in hertz. Excuse me. So in this one, I drew a wavelength, 2 wavelengths in 1 second. So that would be a frequency of 2 hertz. Over here for the transverse wave, I drew 3 wavelengths in 1 second. So that was 3 hertz.